So FRQ number 6, it asks us to find kinetic energy at any time t, and then it gives us a 4 kilogram particle along with the position for x, the function. So since we know the x function, we can also derive it and then turn it into the velocity function. So we know the velocity is equal to x prime. So that's gonna, when we derive this, it's gonna be 1 plus 6t squared, like that. And we know that ke is equal to 1/2 mv squared. So we know that it's 1/2. We know the particle is 4 kilograms, and then we know v squared. So 1 plus 6t squared. So when you just simplify all of that, it's going to give us 72t to the 4th plus 24t squared plus 2. And then that's going to be joules. Part B, that's us to find the acceleration of the particle and the force acting on the particle at any time t. Okay, so we know that acceleration is v prime and then x double prime. So we derive v prime, it's going to give us 12t, like that, and that's our acceleration. And we know that F is equal to ma. So okay, so let me put in the proper notation. So ke, and you plug in the time to find ke, and force, you plug in the time, like that. So we know our mass is 4 kilograms, and we know our acceleration is 12t, like that. And then that's gonna give us force of 48t on newtons, like that. And then for part C, it asks us to find the power being delivered at any time t. So power is work over time. We can we know that work is force times distance, and then that's over time. We see that distance over time, we know that's velocity, so it's force times velocity. And since we both have the force and the velocity function right here, so velocity, and then we have the force function right here, we just plug that in. So power t equals force, which is going to be 48t, and then times velocity is going to be 1 plus 6t squared, like that. So when you simplify all of that, it's going to give you 48t plus 288t cubed, and then that's going to be watts. Part D asks us to find work done on particle in interval t equals 0 and then t equals 2. So ke 0, we know that work is change in ke. So using our functions that we derived, we know that ke 0 seconds is going to be, when you plug in 0, it's going to give you 2 joules. And then ke 2 seconds equals 72 2 seconds 4 plus 24 2 seconds squared plus 2, like that. And then when you plug that all in, you're gonna get 1250 joules, like that. And then we know that work equals delta ke. So ke at 2 seconds minus ke at 0 seconds. 1250 joules minus 2 joules is going to leave us 1248 joules. And that's the work done. Part E, it asks us, does the particle turn around at some point and head back towards its initial starting position? So we know that velocity of the particle is v, is going to be 1.6t squared. So at t equals 0, it's already has a v of 1 meter per second, right? When you plug in 0, you can get 1. And then we know that from there on, t is greater than 0. Since t is greater than 0, when you plug in anything that is over 0 into t squared, any number actually, we know that it's only going to be a positive adding to 1 already. So the velocity is always going to be positive, which is in agreement with its initial velocity. So no, it never turns around. Since the velocity is always going to be positive when you look at the function right here. Thank you.